Good morning. My name is Marita Kotze. I am the Senior Education Specialist for Physical Sciences at Impact. Very welcome to all of you this morning. I'm just going to give a minute or two for the other. I see they are still logging in, so please be patient. I will start the webinar in a minute or two. Okay, while we're waiting, please go to the handout, part to the right on your screen, or at the bottom of the screen, you will see there's a handout. There are 5 handouts. It is question papers, November exam papers. I will explain now why it is November exam papers. So please go and download it so long while we're waiting for the other attendees to be part of the session. So there is also the webinar that I'm going to do now, the PowerPoint PDF, so that you can look at it afterwards as well. So they are still logging in, so let us just see if there will be more names this morning. Okay, I think we can start the session now. And another one. Oh. Okay. Right. I'm going to start the session now. Good morning, everybody. My name is Marita Kotze. I am the Senior Education Specialist for Physical Sciences, and I love chemistry and physics. So yes, and today is my most favorite part of physical sciences, and that we are going to do chemistry. So yeah, before we start the webinar, let's cover the basics first. So if you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining this session. And should you have any questions, you can ask your question in the question box below or on the right-hand side of your screen. Okay. To raise your hand, you can click on the icon on your dashboard below or to the right. You can download this session and this presentation. You can download, and the additional resources you can download as well to the right or below. There are question papers. It is November. There are November question papers. I will discuss that during this session, so why it is November papers. So please make sure that you download that. And if you do have any questions, you can ask me afterwards by sending an email to me, and I will be more than happy to answer your questions afterwards. So please feel free to ask any questions. If you have any recommendations, you can send that through as well. And if they are a part of the term 1 and term 2 work that you're still struggling with, please send me an email and I will make sure that we will have another session, a webinar session about that. So it's just, I'm starting now with term 3's work. I hope you are busy preparing for a June paper, although I'm not sure you're going to write it still, but just make sure that you do cover all the work of term 1 and term 2, and before you start with term 3's work. All right. If we did not get to your question, you can send an email to academics@impact.co.za. Questions in the question box will be answered and made available afterwards. Or if you did not receive the questions and answers, please send an email to info@impact.co.za. You can also visit the Impact YouTube channel for recordings of this session or any other session. If you are not with Impact and I'm using terms and things during this session, you can also send it that you're not aware of. You can also send an email to info@impact.co.za. So please make sure if you do have any questions, you can send. All right. Okay, let's start. Today is chemistry. All right. So we are going to look again at the knowledge area chemical change. The last webinar we did was about chemical equations and the writing and balancing of chemical equations. I hope you already learned the ion tables, both the positive and the negative ions, so that you are more familiar now with writing formulas to write the chemical equations that we're going to use in this part of chemistry. All right, we are going to do quantitative aspects that are the most, or if we look at the ratio of the question papers at the end of the year, you will see that quantitative aspects are the biggest part of your question paper are set out of quantitative aspects, and that is what we're going to do today and concentrating on today. So stoichiometric calculations are the other one. These are two words that I'm not sure if you are familiar with that already, but if you're not, that's why I'm here today. All right, but first I want to cover basic concepts of chemical science or chemistry in any case. All right, so what are basic concepts of chemistry that are what you know on the periodic table? Let me just see, I did insert the periodic table for you here. You can see there are a key on the periodic table. Now that key, the atomic number, the approximate relative atomic mass, the electronegativity, and symbols. Now in grade 8 and 9, you did get familiar with this part of chemistry. I'm not sure how, and in term 1 and term 2, you did cover the periodic table and what it stands for, and each and every the ions that and we did cover it last week as well. So just make sure that you can use the periodic table, and if you cannot, you must start concentrating on that before you start with chemistry and quantitative aspects. Now, just a few things. What is atomic number? It's the number of protons. And if you know the number of protons, you also will know the number of the electrons in the around the 4 in the energy levels. So the mass number is also relative atomic mass. On the periodic table, as we saw it here, the approximate relative atomic mass. Now this part, or the part that we're going to use in the calculations as well in quantitative aspects. So this, especially this one, this number, you will use the most in your calculations. So please make sure that you do know how to use that. So that the mass number is the number of nucleons. Now, what are nucleons? Nucleons are the particles in the nucleus, so therefore it's the protons and the neutrons. So in the core of the atom, you do have protons and neutrons, and they are the lazy boys, because the mass of an atom is all depending on the protons and the neutrons in the atom. All right, so you do know all the elements that you're supposed to know, especially the first 20 elements, as well as the few transition metals that we use in all our calculations like copper and lead and mercury and zinc, all of them, they are transition metals. So please make sure that you do know all the different symbols on the periodic table and what it stands for. So the other thing is, what is isotopes? So isotopes are different atoms of the same element with the different mass numbers. All right, I will just make sure, I will, in any case, I see now, see it's you do have a carbon 12, a carbon 13, as well as a carbon 14. So if we look at that, you will see both of them, all of them, they do have 6 protons. The number of protons does not move. That's constant. The number of protons stay the same in the core. It is the number of neutrons that makes the difference. So that's why we have a decimal number, or else if it will be the same, if it's 6, it will not be a decimal number. So please make sure that you do understand what is the isotope. The isotope is all about the different number of neutrons. Okay, so if there are different number of neutrons in different atoms, then you will see you will have a carbon 12. A carbon, if we weigh one carbon atom with 6 protons and 6 neutrons, it will be 12. But if it's 7 neutrons, it will be 13 because the proton stays, they are the same. All right, and if we have 8 neutrons, then it will be a number 14. So there you can see we have three different isotopes. All right, so there's the periodic table you're going to use in this. Now the second topic we're going to look at the quantitative aspects of chemical change. Now what the heck is quantitative aspects? All right, so let us just look at that. All right, a new concept for you is the mole concept. Now the mole concept is about the atomic mass. If we look again, what is the relative atomic mass? There it is. Remember, I said that's the number that we're going to use the most. All right, so let us just see. So that's where it comes in: atomic mass, molar mass, and formula mass. Now, what are molar mass and formula mass? That we're going to look at the relationship between the mole, the mass of an atom, and the molar mass, composition of compounds. So there are your ions. Why it's very important for you to write formulas. So yes, here it comes in: compounds, what it consists of. Right, water crystallization, percentage composition, empirical and molecular formulas, the molar volume of gases, concentration of solutions, the percentage purity and yield, and the limiting reactants. All these concepts, as you see them, all of them, it's about chemical reactions, what we did in the previous webinar. That's why it's important for you to write a formula, to write the chemical reaction in order, or chemical equation, in order to do all your calculations that you're going to do here. All right, so what is a mole? Okay, no, not the one that's in your garden. A mole. Let us just see if we take, I did bring a piece of carbon. I hope you can see it. I did bring it and I weighed. This is a carbon that weighs 12, a piece of carbon that weighs 12 grams. Now, if we look at this piece of carbon, then we can see, all right, there must be a lot of particles inside this piece of carbon. What is carbon? I get this. You know charcoal? Charcoal, like charcoal that you're using for a braai? That is carbon. It's a black piece of, can you see? Of, if you get it out of the, you can make it from wood, or they get it out of the ore of the earth. So it's the core of the earth. So, right. Okay, so there it is, the particles. So 1 mole of matter contains the same number of particles as there are in 12 grams. So if we take the elements on the periodic table and we take their relative atomic mass and we state it in grams. Okay, so hydrogen is number 1 on the periodic table. Hydrogen, 1 mole of hydrogen is 1 gram. 1 mole of hydrogen gas, if we have, it's 2 grams. All right. So you have the, in chemistry, we can take something and we can see it. That's why I love chemistry. Okay, that is a piece of carbon. So let us just look. I weigh the piece of carbon. There you can see the piece of carbon is fine. All right. There are also the copper are number 29 on the periodic table, and it's 63,5. Now the relative atomic mass on the periodic table, we measure it in units. We cannot say it. So it says 63,5 units U. We cannot, it's not grams because it's 1 atom, and 1 atom is very, very small. We cannot see atoms. Okay, it's with a spectrometer, yes, but not with the normal eye. So 1 atom is very, very small. So now we look at it and we say, okay, I take this piece of carbon, I weigh it, 12 grams. All right, so there it is, fine. When you find the piece of carbon, and there you can see that copper, if you do have a periodic table nearby, the papers that you download just now, that's in the handout box. There's also a periodic table that you can look at. So yes, 63,5 grams. 32 sulfur, 32 grams, if 1 mole, remember, 1 mole. Can you see there's 32 grams of sulfur if we weigh it? You can see that. The atom you cannot see. All right. Mercury. Mercury on the periodic table is number 80 on the periodic table. And if we take the relative atomic mass and we see it in grams, then it is 1 mole. So I hope you do understand what is 1 mole now. All right, because if we look again, 1 mole, I measure as well 58 comma, this is sodium chloride. Sodium chloride is a compound. Sodium chloride is normal table salt that I put in a glass and I measure it. Okay, so this is 58,5 grams. That is the 58,5 grams is the relative molecular mass. That is the molecular mass, because, or a formula mass. So it's a formula mass. So a bit of that more. All right. So now I want to know, all right, if I do have 1 mole, again, the charcoal, 12 grams, how many particles are in this 12-gram piece? Because you cannot see what the atoms are very small. So how many particles do you think is in this 1 mole piece of charcoal? 6,02 multiplied by 10 to the 23 units. In this piece, it is atoms. Okay, there are 6,02 multiplied by 10 to the 23rd atoms. In the sodium chloride the table salt. In the table salt, there are 6,02 multiplied by 10 to the 23rd sodium chloride particles. For particles, yes, because it's not molecules or atoms. So yes, because it consists of sodium ions as well as chloride ions. So the two of them, sodium, there are sodium ions and there are chlorine ions in it. Okay, so that's why we can in any case, it's not a molecule. So formulas are. All right, that are 1 mole, the amount of salt that I put in here, as well as the piece of carbon. Again, so how do you calculate that? In chemistry, you are now going to do a lot of calculations from now on in chemistry. All right, this is a constant number. That's why I say it's a constant. And you will find it also on the formula sheet that are attached to the chemistry paper that you just download. All right. So therefore, atom, 1 mole of carbon contains 6,02 multiplied by 10 to the 23rd atoms. 1 mole of sodium, that is an ionic compound. 1 mole of sodium chloride contains 6,02 mole multiplied by 10 to the 23rd sodium chloride formula units. All right, it's not necessary for you to explain in a paper. That we will not ask how this number of Avogadro's, this Avogadro's number was derived or whatever. That's not necessary, as long as you know how to do the calculations, and that I will show you just now. All right. So there are 3 things that we have here. We have mole, as I explained it just now. We have number of particles that we really want to know, because if I don't have 1 mole, so for example, I have 0.5 mole, how many particles will there be in 0.5 mole? Just divide the number. All right, it will be 3,02 multiplied by 10 to the 23rd atoms. If it is whole a mole, all right, is 0.5 mole. So, but how? It's easy by doing a ratio calculation, all right. But if it's more complicated than the example that I do have here, then you need a formula, to use a formula. All right, the number of mole, the number of the particles that I want to know, and Avogadro's number. All right, so the number of moles equals the number of particles divided by Avogadro's constant. So now, from that formula that's on the formula sheet, all right, you can derive or you can manipulate the formula. All right. It is at this stage, you can please use the formula as you see it on the periodic table and then do the calculation. You can from that manipulate the formula. But the reason why I'm telling you that again is that if you do the manipulation wrong, you will not have any marks for the rest of the calculation. Okay, so usually in most of the questions, you do have a mark for the formula. It's not always, but you will have in some of the questions, you will get a mark for the formula. So if you write it correct from the formula sheet, at least for this calculation, you will get 1 mark. So if you did the manipulation, it's fine. It's not a problem if you do manipulation and you know how to do the manipulation. Just make sure that that is correct. Okay, so the question here is how many molecules are there in 0.23 mole of ammonia? Why are that now? We are talking here about molecules, we are talking about formula units, we are talking about atoms. If it's only one element, if it's only the element, it is an atom. All right. And there are atoms in the 12 gram of carbon. All right, there are atoms. But as we see in sodium chloride is an ionic compound. It is a crystal. It does have a crystal structure. So now we cannot talk about molecules because it's not molecules. It is positive and negative ions that are connected to each other in a crystal lattice. So that cannot be molecules. All right, so that's why we talk about formula units. All right, and if we talk about water and we talk about carbon dioxide, then we talk about molecules. Ammonia, it is a non-metal and a non-metal, so it will be molecules. All right, the bond between a non-metal and a non-metal is a covalent bond, so that's why we can talk about molecules. All right, so now it's easy. By knowing how to use the formula, knowing which formula to use, you can just go on with your calculation. And remember, there's not a unit here, but you need to state, if you write your answer, it's 1,385 multiplied by 10 to the 20th. Molecules if it's molecules, formula units if it's formula units, atoms if it's atoms, ions if it's ions. All right. So let us just look at another question and calculation. How are you gonna find these questions, and what do you need to do? All right. Determine the number of ions that form when 117 grams of sodium chloride dissolves in water. The number of ions, here are your clue. Determine the number of ions. What do we have? We only have the mass here. So, all right. So how are we going to do this? By doing 117 grams of mole. You do have a formula, and the formula I will do it now. The formula we start with is the number of moles equals the mass given divided by the molar mass. This is a calculation that I will show you now. Where do you get that from? So I will come back to this question again. So let us just look at atomic mass, molar mass, molecular mass, and formula mass. All right, what is the atomic mass? The atomic mass, as I showed you on the periodic table, are the 12 grams, are your relative atomic mass, and the symbol for that is atomic. Okay, what is the relative formula mass? I'm not going to read through all of this. You can do it afterwards. Make sure that you do understand, and please send me an email with a question if you do have any questions about that. All right, the relative formula and the relative molecular mass. All right, as I state now, in sodium chloride we have formula units. In water we have molecular units. All right, because we have moles of molecules. All right, so what is the relative formula? If we want to calculate what, say for example, sodium chloride, if we want to calculate the molecular mass of sodium chloride, that's the way we do it. Okay, in this case, it was the molecular mass of calcium nitrate. All right, in calcium nitrate, we have calcium, all right, and calcium, the relative atomic mass for calcium is 40, all right. The relative atomic mass of nitrogen that we do have here is 14, all right. But we can see in this formula here, we have the 2 there at the bottom there. It means that we do have 2 nitrogens, and we do have 3 multiplied by 2 is 6. So we do have 6 oxygens. All right. So 2 nitrogens 2 multiplied by 14, all right? 2 nitrogens is 2 multiplied by 14. 6 oxygens is 6 multiplied by 16 because that is the relative atomic mass. Where do you get that? From the periodic table. Do you know and do you understand now why I said to you in the previous webinars, please know how to use your periodic table, because that is your tool to use in a chemistry paper. All right, relative molecular mass. So what is the relative molecular mass? In this case, it is a molecule. Water is a molecule. So yes, we have 2 hydrogens and we have 1 oxygen. Again, hydrogen, the relative atomic mass is 1, the relative atomic mass is 16. So you add the 2 together to get to the relative molecular mass. Listen, can you see here? We don't have any unit here. All right. Now we say, all right, why? Because we adding units together. Remember, I say to you, as it is on the periodic table, that the units, the protons and the neutrons in one atom is 12. Okay, so 6 protons, 6 neutrons, 12 units. Okay, in my carbon that I do have here, I have therefore a lot of, this is 12 grams, all right, but so that is 1 mole. So now, according to that, we can say, all right, what is the molar mass? The molar mass is when we take because we talk about moles, we say 12 grams, this piece of carbon, 12 grams, okay, sure, I'm getting all black here now, all right. If we say we have 1 mole, we talk about the molar mass. The mass in grams of 1 mole of particles. So if I take the relative atomic mass and I say I want 12 grams, we talk about the molar mass because it's 1 mole. So the molar mass for the molar atomic mass of carbon is 12 grams per mole. The molar molecular mass of water that we do have here is 18 grams per mole, and the molar formula mass. Can you see? So the keynote here is molar. The molar formula mass of carbon nitrate is 164 grams per mole. So we take the relative molecular mass or the relative formula mass and we state it and we say it's grams per mole. So, all right. Now, what is the relationship then between mole, the mass of a substance, and the molar mass? That's the formula that we're going to use to in our calculation that I did here. N equals m divided by m. That is what I did here. I use here the formula N equals m divided by n, the molar mass. So what is the N? The N is the number of moles that I want to derive. What is the 117 grams? That's the given mass that they give in the question. All right. So what is the M here? What is the mass here? The mass here is the molar mass. All right. So the molar mass is 58,5. So that is what we do have here. That is the molar mass. I weigh 58,5 grams of molar, of 58,5 grams of sodium chloride. So that is table salt. All right. So that is what we do have here. So the number of ions, okay, in a sodium chloride, if we have a formula unit here, we have 1 sodium iron and 1 chlorine ion. If we state it in moles, we say, okay, 1 mole, there's not a 1 in front, but if there's nothing in front, we say it's 1. So if we have 1 mole sodium chloride, then we will have 1 mole sodium ions plus 1 mole chlorine ions. So therefore, we can say 1 mole of sodium chloride is equal to 2 mole of ions, the sodium ions plus the chlorine ions. So therefore, we can state here that we do have 4 moles if we calculate the number of the number of the salt that we do have here is 170. That's the given mass. All right. So the mole, you divide it so that you can see how many moles. So therefore, if we need to calculate the number of ions, you use the formula. After you derive how many moles you have, that's the 4 that you get from there. And the number that we want to know, how many are there? Avogadro's constant. Therefore, the number of ions in 4 mole will be 2,4 multiplied by 10 to the 24 ions. All right. So let us just look then here. What type of question do we have here? What mass of iron sulfide is formed when we have 5.6 grams? So again, here we have our mass of iron is completely reacted with sulfur. All right. So now we want to know what mass of iron sulfide is formed. So we're going to work with iron sulfide. So the molar mass that we're going to use here is iron sulfide. Why? Because the 5.6 grams are iron sulfide. Where do you start? You will see you always start with a balanced equation. In all your calculations, if there's not an equation given, you need to write the equation. So that's why we did the writing of balanced equations, and you need to know how to write the formulas. All right, please learners, don't learn each and everything. You need to just start by building the blocks here. Learn the ions, write the formulas, write chemical equations, balance the chemical equations. So please, if you still have problems with that, go back and do that. So because this is the basis of chemistry for grade 11 and 12 for you. So you need to understand the way why we're building the blocks here. All right, calculate the number of moles. We find the number of moles of the given substance by using our formula as we did previously. All right. So now, what is the relationship between mole, mass, atoms of element? Now, these atoms of elements are Avogadro's constant. It is that one. All right. It is Na. It is atoms of an element. Is we want to know how many atoms are there in an element. Okay. So again, here are a combination of, if we want to know the mass of an element, you use your formula, N equals M divided by M. That's your formula, moles of an element. That's your formula. N equals M divided by M. If you manipulate it to get the mass, you put the M on the left hand and the N multiplied by the M to get to the mass, if you have to calculate the mass. If you have to calculate the moles, it's N equals M divided by M. If you want to know the number of atoms, then again, we use the formula, the number of atoms, N equals N multiplied by Avogadro's constant. But if you want to know the moles, you use the atoms of the element divided by Avogadro's constant to get to the mole. All right. So now we can also use this formula if you have to derive from it the atoms, the number of atoms, or the number of formula units, or the number of molecules. You can just use the same formula. Instead of do two calculations, you can combine. But please, again, I cannot state that enough. Again, if you do have a problem with that, please do two calculations rather than doing a combined calculation and do something wrong, and then you will not have impact. All right, so that you can. So now, let us just use these formulas and see in a calculation relationship between the mole, the mass, and atoms of elements. What we did on the previous page. How do you do the calculation? How many molecules are in 3.91 grams of ammonia? Again, your clue, how many molecules? The moment you see how many molecules, how many ions, how many atoms, how many formula units, you must know the question that are asking here. The question that you do have here is the number of molecules, is the particles. It's part of this formula. All right, but before you can use this formula, you have mass. All right, the moment you see the mass, remember the only thing you do have here is mass. So you first need to calculate the number of moles before you can use your formula to calculate the number of molecules. All right, so you calculate the number of moles by using your formula N equals M divided by M, and therefore you have then you can use the other formula. All right. Okay, so what is the composition of compounds? The composition of compounds is what we consist in what ratios and what they consist of. Some compounds require water molecules to form crystals. So here you can see two crystals. You can see blue crystals, and you can see here a powder. Now, this crystal, these products, it's the same, but the only thing that's different here is the crystals on the left-hand side do have water molecules in as well, and the water of crystallization, and that's water of crystallization. All right, so here you have powder. It's a light blue. It's a powder. It's not crystals, so that's why you do have in between the crystals you do have water of crystallization. So we talk about hydrated compounds and anhydrous compounds. Hydrated compounds are the one on the left, are compounds that's like the copper sulfate on the left-hand side, the hydrated copper sulfate on the left-hand side, and the white powder is the anhydrous copper sulfate. With water of crystallization, without water of crystallization. All right. Now, what it is, the hydrated compounds contain a fixed number. So the formula will be salt, X, and the water. All right, so you will see it's copper sulfate is your salt, sodium carbonate is your salt, and that is a fixed number of water molecules in the copper sulfate molecule, and that in the copper sulfate formula unit, not molecule, and that is a fixed number of water in a sodium carbonate crystals. All right, so here we have 5 moles of water are required for every mole of copper sulfate to form a crystal. Okay, so what will you do first? Write the chemical equation. All right, and find the mass of the hydrated salt. I will do an example, the following one. You can go for this one and see what are the different steps. So let's just look at an example. All right, you have the mineral rosenite. contains crystal of hydrated iron sulfide. Okay, so that are the crystals of hydrated iron sulfide. That is the formula, iron sulfide, and you have the X. All right, that is the formula you need to write yourself. Okay, a student wants to find the value of X. In any case, so it wants to derive the number of the water molecules in this crystal, between the crystals. Okay, when iron sulfide crystals are heated gently, they decompose according to the equation. So what is happening here? As we see here, iron sulfide does have water of crystallization. So you heat your crystals, the water will be condensed, and you can see it will turn into vapor. That's part of the crystal here. The water molecules will turn into vapor and then cool down, and then you will have the water in ice and salt mixture. So what will happen here? You do have okay. So calculate the mass of the anhydrous iron sulfide formed after heating to constant mass of anhydrous sulfide. All right, so there are different steps that you need to follow to calculate each and everything. As you can see here, there you have to calculate the molar mass. All right, the molar mass, or the relative formula mass and the relative molecular mass. Relative formula mass, relative molecular mass. Calculate the number of moles. Calculate the number of moles of water, and then you have a ratio of the salt that you have and the water that you have. When you do have the ratio of both of it, how do you do that? You take the biggest one and divide it by the smallest one to get to the 4. Okay, so that the smallest one will be your 1 and the biggest one will be, there's 4 times more of iron sulfate. Okay, so therefore X will be 4 and your formula will be iron sulfate 4 and 4 water molecules. All right, the composition of compounds that we do have here, I see I need to do it a lot more, so I will go quickly through the next slide, and you can just go through it again afterwards and go through all the calculations. Right. So here we have the percentage composition, again a formula that you have the percentage composition of a compound. You use the mass of the element divided by the mass of the compound multiplied by 100. Okay. To see in a compound how many, for example, in water, how many, what's the percentage of hydrogen atoms in the molecule to the percentage of oxygen in the molecule. All right, so what you use the mass of the element in the compound divided by the molar mass of the compound. So the 2 is the hydrogen, the why? Because there are 2 of that, 2 of them, 2 multiplied by 1. What is the 1? The 1 is the relative atomic mass. The 16 is the relative atomic mass. Okay, add them together to get the molar mass. All right, the molar mass is 18 grams. So your percentage is 2 divided by 18. You see 11,11 and 88,89 oxygen is part of it. All right, the composition of compounds. I did include here another example for you that you can go through on your own. All right, now what is the empirical formula of a compound? Indicates the simplest ratio in which the elements of the compound bond with each other. All right, the simplest, all right, ratio in which the elements of the compound bond. So we do have again percentages here, and from that we need to derive the mole. So we state that if you add all these percentages together, you will have 100%. So if we take this and we say, suppose we have 100 grams of the substance, there would then be 36.5 grams of sodium, 25.4 of sulfur, and 38.1 of oxygen. All right. Convert this mass ratio to a mole ratio. If you do have the mole ratio, then you can say, because we don't know what's the sodium, we don't know what's the sulfur, we don't know what's the oxygen. If we derive from that the mole ratio, the molar mass, you use the molar mass of the object. Can you see of the element? The molar mass of the element, you divide it, you get your number of moles with your formula. N equals M divided by M. M is your mass given here. M is your molar mass that you derive from the periodic table to get to the number of moles. Again, the mass given divided by the molar mass derived from the periodic table to get to the number of moles. Again, you have the mass given divided by the molar mass from the periodic table to get the number of moles. You calculate the ratios by dividing the, can you see 0,079 divided by 0,79? It is the smallest one. You divide it by the smallest one to get to the number of mole ratio. All right, to get to the empirical formula. Now, what is the difference between the empirical formula and the molecular formula? The one is the simplest whole number ratio, and the other one is the actual ratio of the atoms in a molecule. So you do the same what we did with the one that I gave you just now. Here they're given the, it's not the mass, they're just giving them the different percentages. You turn the different percentages into grams as mass, divided by the molar mass from the periodic table to get to the number of moles. Get your ratio, that is your empirical formula as we did just now. All right, now how do I derive the molecular formula? By the compound mass. The compound mass, you have again, the compound mass, you did calculate, you can calculate the relative, the molar mass of the molar mass of the compound, and from that you can derive when if you do have the molar mass, you can do the ratio of the one given to the ratio of the one calculated to get to the formula. So you can see that there are two carbons multiplied. So you multiply the mass of molecular formula is twice that of the empirical formula. So you just multiply it with your empirical formula that you do have. All right, what is molar volume of gases? Molar volume of gases is what are the different moles. You can see at standard temperature and pressure is 22,4. You must have the standard temperature of it must state in the calculation that it is STP in order to get to that, in order to use the formula. Again, you get ratios, all right, and to calculate this, if you first have to do that. Now, the concentration of solutions, again, what do we have? If we want to know what I did, here I have 1 mole of salt, here I have 5.85 grams of sodium chloride. So what I want to dissolve it in 200 millimeters of water. So if you dissolved it in that, we want to know what is the concentration. If your mom told you, all right, you have to drink salt water, you want to know, okay, how many salt must I put in water? All right, so if you have to put it in water, you must know how many, and you need to know what the concentration, because I can tell you if you have to put in 2 tablespoons, the concentration will be too high. You will not be able to drink that. Okay, it will be very hard to drink that. So by using different concentrations, you use your formula C, concentration, number of moles divided by the volume, concentration, mass divided by molar mass. Right. You can use the 2 different. You can first use the calculate by using the formula, or if you first have to calculate the number of moles, you can include that in your formula. So it's not necessary to do 2 calculations here. You can just do 1 calculation. Okay, so I must be nearly done. Percentage purity. Here you can see that it's again a formula. If we want to know, chemicals are not always pure, and therefore we need to do a calculation. The formula that you need to know is the percentage purity is mass of pure product divided by mass of impure product. And here is also an example that I put in here for you. Now, the percentage purity, there's a number of calculation in different steps how to do that. Okay, what is the percentage yield is another thing that you need to calculate, and that is the last one. All right, so percentage yield is calculated using theoretical yield and an actual yield. Theoretical yield is precisely what it says. Yield is what's the product that I get out of this. Okay, it's the amount of product we should produce from the complete conversion of a given amount of reactant to product. This must be calculated. The actual yield is the amount of product that is actually formed during a reaction. They normally give it to you in order to calculate the yield. Okay. So here are an example. Can you see here? It is a combination of calculations that you first have to do. You first have to calculate the number of moles, then get the mole ratio, and from the mole ratio you have to get the new mass and therefore do the calculation. So you can go through these questions and must be done. So yes, the last and not the least, the limiting reactants, okay, and the excess reagents. So you need to do the inner calculation. You need to calculate if I do have a certain amount of grams. It always start with a calculate. We always start with I will explain it to you just now. Limiting and excess reactants. So which one? Here you see that the ratio is 1 methane needs 2 oxygen molecules to get 1 carbon dioxide molecule and 2 water molecules. All right. So if I say to you, I do have 5. So the ratio here is 1 to 2. All right, and 1 to 2. So now I want to know which one is the limiting, which one is the limiting one, and which one is the excess reactant. Okay, so here you have 5 methane. Okay, for 5 methane, for the ratio 1 to 2, you need 10. You need 10 oxygen. Here you have 1, 2, 3, 4, 5, 6, 7, 8. So this one will be the limiting reagent, and that one will be in excess. All right. So here I do have again an example for you. The last one are the stoichiometric calculations that you need to do. It is all the formulas that I did until now, use until now. So it's N equals M divided by the relative formula, by the molar mass and the molar volume and the concentration. All right. So here you have, okay, I think our time is up at this stage. You can go through the different calculations and what the steps are. The papers that I put in are the handouts. They are papers that question 7 and 8. The question paper is question 7 and 8 are the calculations that you need to do in term 3 and the end of the end of November exam. So that will be the equations that will be in term 3 test, the questions that will be in the term 3 test, as well as in the end of the in the November exam. So please make sure that you go through these calculations. You will see that we have I just stated as mass calculation, mass volume calculation, volume calculation. The reason why I did that, you will see here you have to write a balanced equation. You have to calculate the number of moles. Now, normally in your questions, you will see that there are different questions and you need to follow the different questions. First, calculate the number of moles. Then you do have a mole ratio of the substances, and from that you convert the number of moles to volume, and in this case you convert the number of moles to get to the mass that you need to calculate. Okay, so if you do have the number of moles, you can do your number of mole calculation, and from that you can derive your mass. Okay, thank you very much for attending this lesson today. I hope you learn a lot, and I hope I didn't confuse you a lot. So please stay put, and you can send me through an email and ask me questions so that I can help you with that. Have a nice day. Bye.